So the motivation behind our project is an 8-year-old named Matthew. He was amputated his left arm due to cancer at a younger age. His family took the advice of their doctor, got a prosthesis for him, but it simply didn't work. This is a common problem among upper arm amputees. And so the bottom line, the problem we're trying to solve is to individualize a prosthesis that meets his needs at a cost that his family can afford.
So 350,000 people suffer from upper limb amputations. 50,000 are added to that statistic each year. Current solutions just don't get the job done. On one side of the spectrum, you have really expensive prosthetics, but really high functionality. And on the low end, you have really cheap prosthetics that just don't get the job done. Hook is simply not an arm.
So here's the big idea. It's called BionUX. We are bridging the gap between the high and the low end of the spectrum of these prosthesis devices. And we're adding a totally new dimension, recreating the sense of touch in a way that's never been done before.
So the big question, why is touch important in the first place? For starters, your sensors in your hand allow you to perceive how smooth or how rough a surface is. In addition, these sensors allow you to perceive how hard or how soft you're grasping everyday objects. Take your morning cup of coffee, for example. If you try reaching out and grabbing without the ability to perceive touch, you're either going to crush it or you're going to spill it all over the counter.
So we have an almost fully integrated prototype that will be ready on April 20th for Matthew to try out. And so what this prototype involves, what we've gotten it able to do so far, is to read a signal from your muscle. That signal tells a motor to close the hand. Once the hand closes around an object, our touch sensors activate and feed that signal back to what we call a haptic actuator at the upper limb. This recreates those textures and forces and presents them to the user.
The first $200 that we received from the Penn Venture Committee has already been used to buy a better motor and ultimately give us a better grasping technique for our arm. The $5,000 that we would receive would be separated into two main phases. Between May and August, we would use $3,000 of those dollars to develop different haptic actuation techniques and allow us to selectively choose the best design for our arm. The remaining $2,000 would go between the months of August and November. During that time, we're going to be making the big transition from a device into a product. That involves buying specific circuit components, miniaturization of different motors and components in our arm, and ultimately making that device a product. So this is a big problem, and a large amount of people suffer from upper limb amputations. And the best part is that many of them would benefit from this technology immediately. The human body is an amazing machine, and it's incredible what people can do with just one arm. But imagine with two. With our technology, that's a possibility. People are not broken. Technology is.